It is the example on page 12 in the lecture notes, in my lecture notes, in this short lecture notes, Introduction to Vectors, the first chapter. But I'll tell you a little secret. There are two problems in tutorial book which are very similar to this one. Absolutely, almost identical. And they mark with the letter H next to it, meaning that they are harder problems. I can even open you the secret. It's the problems number 21 and 22. So after we're done with this question, those two should be very easy for you. So here's what the question says. It says, imagine we have 3 points, and this time we just look at the two-dimensional space, but it's not a big difference. Two-dimensional, three-dimensional, whatever. We have 3 points, A, B, and C, with given coordinates, like this. Now, the question is, where should we put the fourth point, point D, such that the ABCD becomes a parallelogram? And of course, we have to identify the coordinates of this point D. Now, if you look at that question, the first thing, or if you look actually, I don't think it's said explicitly in the lecture notes, but it is said in the tutorial book, I think, that there are 3 different answers to this question. And if you didn't have this diagram, probably you would just ask me why, but the diagram probably explains everything. Why exactly there are 3 possibilities for the point D to be, to make ABCD a parallelogram. One of the possibilities is here. So when you take A, B, D, C in this order, the other possibility might be if you change the A, B, and C points in a different order, A, B, C, and D, that's it. Another possibility for the parallelogram. And the third possibility yet, it's when you take point D in here. Do I have the picture for that, by the way? That's the third possibility. Each of these possibilities should be addressed individually. I mean, if you want to find the coordinates of the point D2, you have to do it one way. If you need to find the coordinates for the point D3, you have to do it the other way. D1 is the third way. I did this question, in fact, I'll give you another little secret. I did this question last year, and last year we found point D1. D2 and D3 are left for the class to find. This time I can find, for instance, D2 or D3. The solutions, they are similar, but if you're struggling with the other point, while I showed you one point, you can visit that solution. And I will publish this on the website. Yes, please. Well, you're sort of referring to this unspoken convention that when you write the letters in the name of the parallelogram, you expect them to be like, in a circumference. But if you trash that convention, which I think that's where the trick in this question comes in, they just silently ignored that convention and left it for you to figure that out, that they left it out, this convention. You're right. Strictly speaking, I have to change the notation, but I change the naming of my parallelogram. But if you forgive me for not doing so, then the question is still legitimate, isn't it? Well, it's a very simple problem, in fact. As soon as you identify this triple of different solutions, the possibility of triple different solutions, it's simple vector manipulation, which now involves also the coordinates. So all I have to do now is to, for instance, if I want to find D3 point, I have to take this observation that the vector B D3 is the same as the vector CA. For the CA vector, I can find the coordinates of that vector, can I? Because I have the endpoint and I have the origin. You see, my software suggests me the coordinates, but actually, yeah, that's in the right order. So here's the coordinates for the CA vector. Right, that's the coordinates of the endpoint. That's the coordinates of the last point of the origin. The software didn't do any arithmetic, but we can ask politely for that too. That's the CA coordinates. Now, after the arithmetic is done, if I know CA, I know also BD3, because these are two vectors which are identified by parallel transition. Right, so if I sub this in here, these are the coordinates for the BD3. They're just identical to the coordinates of CA. And now, if I want to find these coordinates, Well, we can do now the reversal process, isn't it? I mean, the direct process is when you know the coordinates of the endpoints and you conclude the coordinates of the vector. The reversal process will be when you know the coordinates of the vector and the coordinates of one of the points, one of the endpoints. And then you can, by reversal process, you can find the coordinates of one of the remaining endpoints, I'm sorry. So again, I think software can help me with that. If I use this vector and if I supply this with the coordinates of the point B, let's just see, yeah. We can do the coordinates of the point D3, like this. Again, the arithmetic is not done here. If I do the arithmetic, this is D3.